Hi, good morning, afternoon. I'm Sergio Gomez, and I'm going to present you the accounting and impacts of embodied energy and embodied carbon in Passivhaus. In a Passivhaus that is located in the UK. This research started as part of a dissertation and master dissertation program in the University of Sheffield, and I have been collaborating with the Professor Fiona Stevenson, Jenny Brierley, and Frank Bradshaw, who was the architect of the house. Just to getting into the point of what is what, we understand embodied energy as all the energy involved in the extraction, production, and transportation of a material, and embodied carbon with a similar definition, that is all the carbon emissions produced by that extraction, production, and transportation of a material. We use the framework and guidelines of the Royal Institute of Chartered Surveyors because they have a wide information about this, and we use this to guide our research. Um, just to describe a bit the methods and the research approach, obviously because we understand the weakness of the case study, we try to robust that study and doing post-occupancy evaluations, interviews, and site visits. And this was mainly to understand if the user have done some changes of alterations to the house. The house was already used by the end of 2015 and beginning of 2016. We extract the information of embodied energy and embodied carbon of environmental product declarations and the ICE database. That now the version 3 is just accounting for embodied carbon, and sometimes we need to go back to the version 2 to account the embodied energy. The case study and the case study and the house has 3 bedroom because it's supposed to be used by 3 people, but it's just used by one. So obviously this has impacts on the operational energy and operational carbon. Well, we understand that because of the passive house requirements, the fabric needs to be really robust, and we can see it because it's using 300 millimeter mineral wool insulation. That's well, it's a way it's a higher standard than the usual in the UK. When we start accounting for the embodied energy and operational energy, we got really interesting findings. For example, we get that it was just 34.65 kilowatt hours per square meter per year, contrasted for what Passivhaus requires, that is 120, and was a way lower. Probably it was related to the number of users or different circumstances. And the embodied energy was the total one. It was almost 160, 100,000. That if we contrasted the operational energy in a span of 100 years, the embodied energy represented the 36.19, and it obviously it was a quite high impact on the whole life cycle. And for example, we also get that the major impact was being made on the external walls, that it was the 27%. And when we start looking at the operational and embodied carbon, we got even more interesting findings. For example, we understand and we get that the embodied carbon was 59,000 kilograms of carbon emissions, and we use the same 100-year lifespan to get the operational carbon, and it was 97,000 kilograms. So this was significant because it means that the embodied carbon represents almost the 61% of the whole life carbon. So this is quite significant. And also we model the house in Revit, using Revit and using a plugin called Herbert that was developed by Hawkins Brown to understand the embodied carbon emissions. And when we contrast our methods with them or outputs, we get that our embodied carbon was almost 30% more than them. And obviously, because the carbon and the embodied energy, they are correlated, we get that the element that was uh, getting more embodied carbon was the external walls. And because of this understanding of that the external wall was having a significance in the embodied energy and in the embodied carbon, uh, we try to do an approach of a substitution. So we substitute the high intensive materials as the inner block work and mineral wool. So we substitute this for clay brick and natural wool, and in the overall, we get that we can reduce in almost 5% embodied energy, but in an 80% the embodied carbon. And well, just to conclude, we see how the use of high intensity materials to comply the Passivhaus standard, um, they have a quite high significance on the embodied carbon and embodied energy. So, and also we understand that if we use natural materials or well, low impact materials, we can still keep the Passivhaus standard and requirements, but low this embodied energy and more the embodied carbon. Obviously, the research needs got limitations, and we keep looking forward for doing more research about this. And well, by now, this is it. Thank you.